Hello, welcome to circular motion. In this video, I'll talk about a classic example of circular motion where you can see in this picture behind me, there are some cyclists on a bank track. Okay, so let's observe how the cyclist is cycling in the curve of a circle. In fact, these two people are about to overtake them. You can see they're like looking to the back. So let's go. I purposely slowed down the video so that you can observe how the cyclists lean their bikes as they take a corner. All right. So you can see that they tilted their bike and they lean towards the corner that they are turning. Okay, so if you were to imagine that this is the center of curvature, so this is the curvature, the center of circle is somewhere here, okay, maybe above my head, center of circle is somewhere here, and they're actually making a turn this way. They are leaning in towards the direction that they are turning. Okay, so let's look at it again. You can see from the other side, the same thing will happen. The cyclists are leaning inwards, and then when they are traveling out of the corner, they will straighten their bike again. All right, so here's another picture for you. I'll pause it. You can see they're leaning towards. So this is a bank curve, right? Center of the circle is here, and they are leaning towards the center of the circle. Okay, but why do they need to lean towards the center of the circle? I mean, let's think about it. The condition, based on your understanding of circular motion, is that whenever you want to take either a full circle or part of a circle, the condition here is that the net force acting on the object has to provide the necessary centripetal force. Meaning, based on how this cyclist is leaning, it needs to create a net force to provide a centripetal force such that the centripetal force or the net force is directed towards the center of the circle. So the reason why the cyclists lean in such a way is such that the wheel of the bicycle feels like it is sliding up the inclined plane, meaning the friction will slide in this direction. All right, so it might be very abstract. So now I'm going to just show you and draw out the forces on a more simplified diagram. All right, by the way, this is a CAIE cycling match. There are many different types of cycling match. All right, so let's go and draw the free body diagram. Okay, so you can see this is the free body diagram of the cyclist. All right, super simplified. And he is traveling in a circle of radius 50 meters at a speed of 20 meters per second. So he's making a turn. All right, so this is a 2D drawing of the diagram that, or the video that we have watched just now. All right, the combined mass of the cyclist and the motorcycle. So in case of, instead of a bicycle, this is a motorcycle. All right, so this is the combined mass. Calculate the combined weight W of the motorcyclist and the motorcycle. So before I attempt to answer the question, let us analyze the forces that they label for you first. Okay, so I need to read the question to try to understand what the symbols represent. So for example, in this particular question, it says W is weight, so this is pretty straightforward, and R is your vertical reaction force. So if you remember what reaction force is, right? Reaction force, or sometimes known as normal force, I'm just going to call this normal force. The fact that the name is normal means that it has to be perpendicular to the contact surface. So the wheel is in contact here, right? It's touching the floor. So the so-called perpendicular to the contact surface will be in roughly this direction, pointing upwards, like so. Okay, so along the center of mass or the line of the body this way. This is our end. Okay, so you can see the reason why we lean, or you lean towards the center of the circle, because the center of the circle is here, is so that this F gets to provide the necessary centripetal force. Okay, so it gets to provide the necessary centripetal force, and this force is friction. Friction between the wheels and the track, the curved track. So I'm just going to be a bit more specific here. That's why there is a lean, okay, between the wheels and curved track. And that leaning allows this F to act towards the center. You lean away. This point of the wheel is leaning away. It's about to slide in this direction. Because it's about to slide in this direction, friction will act to oppose the slide. Okay, a lot like the leaning ladder on a wall. All right, Okay, so we have friction here. It will provide the necessary centripetal force. And this R is the vertical component, vertical reaction force. So this means this R is actually this N resolved. Okay, so if I resolve this N, dot, 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 I'll get my R, and I will also get a horizontal force in this direction. All right, so this is actually N, no angle here. So this is N sine theta. So this vertical component is N sine theta, right? Okay, so this is what is happening. Of course, you might be thinking, if this F is the one that provides the necessary centripetal force, the friction that is pointing towards the center of the circle, and the other reason of leaning towards the center is because your N cos theta can also kind of help. All right, so we're going to try to start the question now. A part 1. Calculate the combined weight of the motorcyclist and the motorcycle. So I'm going to zoom out a bit so I can write. So we know W is equal to mg, so this is just like a warm-up question. That will be 250 times 9.81. All right, and let me get my calculator. Okay, so this is 2450 Newton. And if you want to find the vertical reaction force, all right, so here you will see that this motorcycle is not floating up, it's not floating down. I mean, it's not accelerating up, it's not accelerating down. So the upward force and the downward force must be the same. So if let's say I take this point here, let's say I call this point P as the pivot. Okay, so if I look at the forces acting on point P, after resolving, I will have this vertical component of N, which is N sine theta or R. I will have this horizontal component of N, which is N cos theta. And I will also have the frictional force or the value of F. But actually, they didn't mention that F is friction, by the way. Did they? They didn't. So I shall withhold my judgment on whether this F is actually N cos theta or friction plus N cos theta. Don't know. So I'm just going to put a question mark here. Not sure. Okay, but what I do know is that there is an unbalanced force pointing in this direction. So what are the other forces acting on the system? You have W, and W, because it's pulling downwards. This is the weight W. Okay, so this downward W and this upward R has to balance or cancel off. If not, then the bicycle will just rotate or it will accelerate upwards, which is just weird. Okay, so again, I'll just draw the W here for you. This is your W. All right, so W is equal to R, which is equal to 2450 Newton. All right, upward force must be equal to downward force. The only unbalanced force that is allowed to remain is the forces that is directed towards the center of the circle. And in this case, it will be this. I don't know, is there any friction? I guess we'll have to continue the question to figure out. All right, so this is part 2. Part 1, part 2. Let's look at B now, after I label the question. Part 1 and part 2. All right, so let's look at B. Calculate the centripetal acceleration of the motorcycle and the motorcyclist and show that the centripetal force F. So F is not friction, okay? So sometimes this kind of question is very important, like as mentioned before, to read, because I've been doing so many questions, sometimes I make my own assumptions. So you can see that my assumption here is not correct. So we go back and correct our mistakes now. So is there friction between the wheel and the curved track? I guess I need to do some maths to figure it out. But this F is not the friction that provides the necessary centripetal force. It says here that the centripetal force is F. So this F is centripetal force. Centripetal force or net force. And you might be wondering to yourself then, is this force made out of friction? Sure, maybe, but it's also made out of N cos theta, definitely. So is there friction or not? Don't know. need to calculate. Okay, so let us find the value of FC first. Okay, so let's see if we want to find FC or centripetal acceleration. This will be v squared over r being the radius of the curvature. So I have the radius, which is 50 meter, and the speed, which is 20 meter per second. So I'll substitute that in. All right, so this will be, let me scroll this up so that my head is not blocking you. So this will be 20 square over, the radius is 50. So that'll be 400 over 50, which is 8 meter per second square. And for part B, if you want to find centripetal force, you will take MAC. This is a textbook question, so they try to guide you along the way to make sure you understand. All right, so that one would be 250 kg times 8. I'm just gonna, so this is 2000 Newton. All right. So in this case, we have already established that the centripetal force needed is 2000. But the question here is is n cos theta enough? Because the question just is this 2000, or do I still need this? All right. So I guess we will have to continue the question. So B is done. Part C. Explain what provides the force F. So I guess to answer that question of whether this n cos theta is 2000, I will need to find the value of theta. Okay, like show that the angle theta is 50. So what kind of assumptions do you have to make? Okay, so in this case, right, the assumption that I will probably have to make is, okay, so let me try to explain this to you. So right now, our situation is this. We have our cute little bike represented as a rod, okay? And we have the vertical component of the normal force. I will try to use back the same color. Give me a sec. But think about all the forces acting on. So normally when you're studying this kind of thing, it's pretty normal to draw out the forces or the free body diagram again and again. It's a normal thing. Even I have to draw it. So this will be R. Okay, R and mg will cancel out because again the motorcycle is not accelerating upwards or downwards, and this R happens to be n sine theta. Okay, where n is the normal force that is here. So just draw a dotted line because I've resolved this. All right, and of course this n will also have a horizontal component here. All right, badly drawn, but I think you get the idea. This is theta, and this will be n cos theta. So this is also the direction of the net force F. Okay, so if this is the direction of the net force F, the question here is just, is there friction? If there's friction, friction will also act in this direction. So I'm just going to call friction lowercase f. So if there's friction, the net force is n cos theta plus f. So this centripetal force or this net force theta will be n cos theta by f. But there may or may not be friction. The question didn't say. And in fact, if they say state any assumption, right, I might assume that, oh, it's the assumption that they want me to make. Okay, so let us try to find theta first and then cycle back to try to explain C. Okay, so let's say that the assumption is there's no friction between the wheels of the motorcycle, and the track. So because of this, your net force, which is equal to your centripetal force, will also be equal to the horizontal component of your reaction force. All right, so this n cos theta, again, is the horizontal component of your centripetal force. Okay, so we have this. This is 2000. 2000 will be equal to n cos theta. Okay, do we have n sine theta? What we do? 2450 is R. So remember previously we know R is equal to W is equal to N sine theta, which also happens to be 2450. So I'm going to write here. Also, 2450 is equal to N sine theta. So now I don't know about you, right? Because I got two unknown. My unknown is N and theta. And a common trick is that I will divide equations like this. So let's say this is equation 1 and equation 2. I will take equation 2 divided by equation 1 so that I can arrive at the tangent theta. So 2 divided by 1 is equal to, so I can cut off this one. I will get sine theta over cos theta. And that sine theta over cos theta will be equal to 2450 over 2000. So tangent theta will be 2450 over 2000. And I guess we could press our calculator to see if this is indeed 51. So tangent inverse 2450 divided by 2000. Oh, 50.77, which is about 51 degrees. So this is proven. All right. So what does this mean? This means that friction is not helping you. So just now at the beginning of the video in the introduction, I hope you are aware that there's no such thing as two surfaces with no friction. No matter how smooth and how much KY jelly you put, there will be some friction. Why? Because surfaces can never be uniformly even in the microscopic scale. But in this case, maybe the friction is small and negligible, okay? And so the angle here will be 51. If the friction is small, this means that the centripetal force is only due to N cos theta. And the thing about friction is that it will act where you are about to slide away from. So in this case, since we have enough stability, all right, and if you notice, the wheels are all very thin, so the amount of friction is actually also quite negligible, especially if you are riding on high speed. So this friction here is small. So to answer this question of small or equal to 0, and to explain what provides the force F, it is not friction anymore. It is not friction because, number one, the question didn't mention that there's friction. And number two, if I make the assumption that there's no friction, then centripetal force is totally provided by the, whoops, sorry, my OneNote is laggy. Hello? Okay, so centripetal force is provided by the N cos theta. Let me scroll a bit. There we go. Force provided by N cos theta. So it is provided by the horizontal component of the reaction force. So once again, the very important idea in circular motion is centripetal force is net force provided by any forces based on the analysis. So you have to analyze the scenario. Every scenario is different. Sometimes tension will provide centripetal force. Sometimes horizontal component of the normal force will provide centripetal force. Sometimes weight will provide centripetal force. Read the question and analyze it so that you understand what provides the centripetal force. So in that case, we can seal the deal for part C. What provides force F? This will be the horizontal component of the reaction, normal reaction force. Okay, so again, you have the normal reaction force here. I'm just going to highlight in green for you. This is your normal reaction force, this direction. Okay, and we split this into two components. One is the vertical one. Vertical one is N sine theta. N sine theta will balance W so that the motorcycle don't accelerate up, don't accelerate down. First equation, N sine theta is W. Second equation, N cos theta is directed towards the center of the circle. Okay, directed towards the center of the circle means it will provide the necessary centripetal force. So N cos theta will be equal to Fc, which is what is meant here lah. Okay, centripetal force F. provides the force F, horizontal component of normal reaction force. Okay, and finally, once we have these two equations, we can divide them to arrive at the angle 51. So that's it for the question. It's very familiar with the conical pendulum. So do also check out the conical pendulum examples, probably in your books or in the other videos. And thanks for watching. If you find this helpful, again, please share with your friends and like and subscribe our videos. And go and watch some cycling videos to brain the centripetal forces. All right. So that's all. I will see you in the next one. Take care.